Okay, entonces rational function, the name rational indicate us fraction. Is the division? Division what? Division 2 polynomial. Division 2 polynomial. So you have the rational function, let me call capital R, is equal P of X divided by Q. This is the traditional letter using in this chapter. P numerator, Q denominator. And the first thing that you should do, I explained last class, is express this in factorial form. In other words, your factorization, you see your skill in the factorization. Factorization who? Factorization the top and factorization the bottom, both, right? Now we can determine domain. Okay, by the way, domain is always the value que satisfy this condition, Q, no zero. Okay, this is the guy que control the domain is Q. P no important to determine domain. Entonces we discover que sometimes the function, that function is to be undefined when Q is zero, and we have two possibilities. The first possibility, que es the most popular, que es the vertical asymptote. And the other is the whole. This is weird, okay? No frequently, not often happen whole. But it's okay. How do you know? Well, when one factor is cancelled out, suppose hypothetically, suppose we have x minus 2, x minus 3, and the top. And the bottom we have x minus 2, x minus 3. Wow, it's the same. And x plus 4. Okay, you know, in intermediate algebra, okay, that part cancel, and that part cancel. And stay only alive x plus 4 in the bottom and nothing in the top. Okay, well, this expression and this expression are equivalent. Are equivalent. Let me write. And the other board, I have a tool. Okay, I can do under, but on this no. In the old version of the whiteboard Microsoft. Okay, entonces this is igual. Bueno, yes, pero under the restriction que x is no 2 and x no 3. This is equivalent. So we can, and we have the original problem is given like that. It's very, very complicated. Very, very complicated. And how you, from now, you working with this, que it's easier. But the idea that you have in your mind, that this is valid for all number, nice. But the bad guy is 2 and 3. 2 and 3 is different. 2 and 3 represent the wholes, of course, to be undefined, the original. And at x, let me copy it separately. At x equal negative 4 is the zero of that part, is the vertical asymptote. Okay, entonces now, see you talking about domain. Okay, domain. Domain is all real numbers such that the function no 2, the function no 3, and the function no negative 4. This is the 3 bad guy. It's impossible to evaluate here because the answer is error undefined. However, it is important to separate chicken in 2 pieces. This responsibility to be undefined for these 2 and 3 as a wholes. And the responsibility here is because it's very fast. And we study in detail today both graphically. You see the differences, right? But we start for the verical acetone. Verical acetone has its name say it's verical line. Boom, 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 boom. Verical line. In this case, at x equal -4. And the curve, when you learn how we are doing the curve, when the curve approach to this, however, like that, but never touch, never touch, approach. Now the distance between this line, so this line do not participate actually in the graph of the function. However, it's the important piece of information can help us to understand much better the graph of the function. Entonces, the asymptote is super important. It's mandatory. When the I ask you, do the graph of the rational function, that you need to analyze any asymptote. Any asymptote. Entonces, basically, what is the formal definition of the verical asymptote? Well. Verical asymptote definition is let me see, definition. When the x value approaches to the one specific number, in this case -4, but in general I want to call C. C is -4 in this problem. Look at that. The y value or f of x, either way you can call, approach to positive infinity or negative infinity. So it's going, in that case, it's going up, and in this case, it's going down. It's a huge number. Infinity, remember, is no number. We cannot perform arithmetic operation using infinity because you make a mistake. However, it's a symbol can indicate us okay, this is function blew up or blew down. So it's a huge number positive or huge number negative. So we have different kind of the verical asymptote that you found you will find in the problems. Look, we have 4. 1, 2, 3, and 4. We have, for example, one verical asymptote like that. The convention so far, guys, in Desmos, because everything we are doing in Desmos because it's too complicated. So the convention is the any asymptote, verical or another asymptote we studied today, is dotted line, bam, 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 and black color. The color we use in convention for now is black. And style. I suppose it's like that, is dotted line. To differentiate, of course, with the axis, the axis is solid line. Suppose we have 4 scenarios. This is very gas. Okay, now, suppose the function like that. Suppose that this value is 2. Let's suppose hypothetical 2, 3. But 2. I need to make a decision 1 or put the letter C. No. 2 is better for me. So in this case, f of x, suppose que es 1 over x minus 2. Oh, entonces the curve look like that. How do you know that? Well, using this super easy approach. Look, you know again 2 is undefined because 2 minus 2 is 0 and 0 the denominator to be undefined. However, you evaluate a little bit after 2, suppose 3, or 2.1, 2.3, but 3 is okay, and 1 is okay. And when you evaluate f and 3, you have 1 over 3 minus 2, no? 3 minus 2 is 1, and 1 divided by 1 is 1, it's positive 1. You determine que es positive. At least the sign is positive. At that point is the point 3, 1. Likewise, you evaluate in 1, que es to the left. It's 1 over 1 minus 2. 1 minus 2 is negative 1, and 1 divided by negative 1 is negative 1, or is negative. It's negative. Entonces you determine that behavior. You see, one professor, what is the reason can I complicate this? No, not complicated. It's 1 comma negative 1. It's because we have another kind of the Berry asymptote, no? Suppose we have that. Look, f of x equal x minus 2 again, no? But you put here negative 1. Either way, you put negative 1 here, or you put negative 1 in the front, doesn't matter. Oh, I don't understand. Okay, this is very, very similar to this, but we have a transformation. What kind of transformation? When we have reflection. And see, we have reflection doing, for example, the negative part become positive, and the positive part become negative. Do you see that? A reflection. And so you have negative, not necessarily 1, guys, because you suppose you have negative 2 or negative 20. You know, que it's the same shape. The only thing is doing the 20 is a vertical stretch, but it's the same shape. Okay. Everyone follow me? I promise in a few seconds we are doing example and we understand much better. This is theoretical introduction. Now suppose, follow me. Yes, Sophia. F of x equals, suppose another possibility, f of x equal another possibility. Suppose we have one number, 1, but you divide by x minus 2 again, but a square. Wow, a square. And not necessarily a square. You know, when you raise to the any exponent case, even numbers 2, 4, 6 happen the same situation. So you know, okay, always in that scenario, the value of the function is always positive. Entonces, like that and like that. In this case, both approach it, go to the positive infinity. No, in this case, approach it to positive infinity and negative infinity. No. And suppose reflection. This case reflection is minus something. X minus 2 is a reflection. Entonces, this reflection look like that. In this case, go to the minus infinity. Super cool, super clear. Well, si it's clear, let's do the first example. Because in the test, the thing you should do is I give you a graph of the rational function, and you need to do. So I give you, sorry, the equation, and you need to do the graph. But using any property. We study property. Maybe this class is too long. Maybe today we discussing the typical thing. And I prepare for you 3 examples to ending, but not today. I suppose today we have no time. We continue Monday with this. Okay. Entonces now example 1 is super easy, like every example 1 is the first. Is 2 over x minus 3. Oh, entonces now I see in the denominator x minus 3. It's obvious that you take the expression in the denominator, you enforce it to be 0, x is 3. And this is the domain. See, I say, what is the domain, professor? Well, the domain is all real number. Domain of the function f is all real number except 3. And 3, we have a vertical asymptote for sure. And the vertical asymptote, well, you need to understand si es de behavior 1, si es de behavior 2, si es de behavior 3, o es de behavior 4, ¿no? Es obvio que 1 o 2 because there's no square. But I suppose you by compare, but at this moment, maybe I don't know very well because I have no this image in front of me. Entonces yo evalué, you know. First of all, the graph look like that. A tree, 1, 2, 3, we have a famous vertical asymptote. Okay, let me write like that. This is vertical asymptote at x equal 3. And you evaluate before, this is 3. And after you evaluate 4, and you evaluate 2. Okay, so you take the original function notation, evaluate 4, is 2 over 4 minus 3 is 1, and 2 divided by 1 is 2. And the famous point is the point 4, 2. And you plot that, 1, 2. My point. Evaluate at 2 is 2 over 2 minus 3 is -1, entonces 2 over -1 is -2, and the point is the point 2, -2. Okay, it's down. Entonces, -1, -2 here. 2, -2 look like that. We can do more points, but the beauty of this is que no necessary. Now, because you take advantage the idea que this is the vertical asymptote. Entonces, now I suppose que my curve approach but never touch this. In this direction, I have no clear idea, pero something like that. Okay. We study another property in a few minutes. Okay, you see what is the continuation in this direction is not clear. In this direction is clear, in this direction is clear. It's a go to positive infinity. It's go to the negative infinity. I have no idea exactly what happened here. I don't know what happened here. But in a few seconds, you understand very well. Do you understand this example very well? That you plot 2 points before and after the asymptote. You determine the behavior, in this case, behavior number 1. No? This is the name I create to explain this, but the book never using behavior number 1, number 2, number 3. The book using the picture, that picture, this behavior, or this behavior, to say now you can be, it's behavior number 1 or behavior whatever, the picture. It's clear this example 1?
Yes.
Let's move on to example 2, a little bit more complicated. Example 2, the name of the function is g. And remember, rational function is division to polynomial. The polynomial in the top is x minus 3, binomial. The polynomial in the bottom is trinomial, x squared minus 5x plus 6. What is the first thing that you should do always to analyze this kind of function? Factory 4, factory 4, factory 4. In the top, we cannot do anything because this binomial is prime. We can know, but on the bottom, yes, it's trinomial. Immediately I am doing the factorization. It's obvious because we are doing several times. The combination is 3 and 2, no? 3 times 2 is 6, 3 plus 2 is 5, and both negative. Yes or no? Wow. Entonces, in that moment, I see, wow, this is cancelled out. This is cancelled out. But the factor gets cancelled always is a whole. And the factor can stay alive. Then the top we have nothing, the bottom we have x minus 2. Okay, now the other value gets 2. So at, I realize in that moment that at x equal 3, we have a whole. Let's see how you represent the whole. If at x equal to, because the zero of the Parker remain after the simplification, is a vertical asymptote. Cool? It's a vertical asymptote. Okay. So now so far, see, I doing the graph by hand. Never I do it by hand. I do in Desmos always. I want to show you Desmos now. But well, let me try at least one. And the confusing part for the student is, well, professor, so we can use this expression to evaluate, or we can use this expression to evaluate. Well, this is the same, except in the whole. Except in the whole. So we can affirm that x minus 3 in factory 4 or no factory 4. Suppose this, x minus 3 again. X minus 2 is equal 1 over x minus 2. Well, 99% of the time, but not 100. Because this is equivalent and x not 3. O sea, conclusion, in few words, super short, you can evaluate, for example, f in 5. Or f no, es g, no? The name of the function is g. You evaluate g and 5. Well, you can plug in this 5 here or here, either way, because it's not 3. In my opinion, it's easier doing this because it's short. And you evaluate in another number, in 8, or negative 8. We're using again the short, okay? Where is it invalid? No good. Entry. Entry. So you need to evaluate entry. Okay, by the way, it's undefined. You evaluate not here. You evaluate 3 minus 2 is 1, 1 divided by 1, 1 is totally wrong. You evaluate here in the original. It's undefined. In 2, you can evaluate in this one, this, and either, because of the asymptote, it's also undefined. Because the domain of this function is all real number except the whole and the vertical asymptote. This is confusing or is clear? Let me know.
It's clear.
It's clear. Okay. Now let's see what happened in the graph. In the graph, you need to represent both. 1, 2. This is 2. And 2, I do my famous vertical line. X equal to line. You evaluate a little bit, but you don't evaluate in 3. No, because 3 is undefined. But I evaluate in 4. Not necessarily exactly 1 to the right and 1 to the left. It's to the right, 2 unit, 3 unit, 4 unit, to the left, exactly the same. So you evaluate, for example, N1, G and 1. We can use, of course, the short expression, the easier. 1 over 1 minus 2 is 1 divided by negative 1 is negative 1, and the famous point is the point 1 comma negative 1. Nice. 1 comma negative 1. This point belong of both, of the original and the simply way after the cancellation. Cancel out the x minus 3. Entry, no, illegal violation. But in 4, yes, why not? G and 4, we're using one more time the easy, in my opinion, que es 4 minus 2. 4 minus 2 is 2, is 1/2. And the point, the famous point is 4 comma 1/2. In the y value. 4 comma 1/2, I suppose que this is 1 positive, 1/2 is the middle. Okay, and this is the second point. And also, I know the behavior que is something like that. Look. Ooh. I make a mistake. Ooh. Approximately. You know, the idea for this is not clear so far. The clear of this, yes, is infinity and negative infinity. But I forgot, Professor, you forgot the whole. Yes, I forgot the whole. The whole is in 3. So in 3, we have a whole like that. Let me erase something. No, I cannot. I cannot erase. I cannot erase. Boom. It's a whole. It's a whole. Okay, boom. This is the point. Okay, I try to do my best. After, and when I finish this, I put in decimal elegant way. Yeah, I want to explain how you should do in the test. This is a whole. And the whole is at 3 comma something to be undefined. That is the reason it's a whole, no? It's undefined entry. However, you have to get idea in what value lie this. Well, use substitution and the original, no, and the after the simplification, que es 1 over 3 minus 2, que es 1 over 1, que es 1. So the point is the point 3,1, but this point 3,1 belong to this expression and do not belong, no, do not belong to this and do to this. But I using like a reference to have some idea where look like or state this. By the way, this one is my scale is a mess, of course. Let's do it in this one now. Do you get the basic idea or no? When you face the problem of the rational function, the first thing you should do is factorization. If very seldom happen, but happen. Some factor cancel out. Boom. This is a whole. And the representation of the whole is like that. You put the curve, but in the place of the x equal 3 is to be undefined. And the symbolic way to indicate you put a whole, right? However, the factor that stay alive in the bottom represent the vertical asymptote. Okay, and then the vertical asymptote, you remember that my function blow up or down. It's positive infinity or negative infinity. Let me try. Let me try to show you in detail this idea. Let me try. This is complicated. This chapter is complicated, I know. Let me try to share the Desmos, no? Okay. Do you see Desmos? Do you see or not? Yes, no?
Yes.
Okay. The example 1, that was easy, was the function 2 over x minus 3. And this is another fantastic way, guys. You take advantage function notation. Instead of put the y, you put f of x, either way, the way that you prefer. But what is the advantage of this? Okay, you allow Desmos compute by itself the y value. You indicate like a function notation, fn2, fn4, and you get beautiful answer. Let me show you. In this case, obviously, the graphic you watching this now is a rational function whose domain is all real number except 3. 3 is the bad guy, and we you see clear how the curve go to positive infinity when you approach it to 3 to the right, or go to the negative infinity when you approach it to 3 to the left. It's the behavior guy categorized like a what behavior. Okay, cool. This is easy. However, example 2 was a little bit more complicated. The asymptote is in 2. Let me show you. Look, I copied the original. X minus 3 over x squared minus 5x. And suddenly happened, magically happened, that 3 do not participate in the game. because the only asymptote that we have is at x equal 2. The behavior is the same, but the new thing is in 3 we have a hole. And the hole, well, you represent like a point, 3,1, but you using different style. Okay, this is the point, and you using different style. To see the style, you click on the icon and you click or left click in the mouse and you hold press the hold in the icon and you select the color that you prefer. Okay, by the way, I suppose that the best color is the same color of the curve, okay, blue. I don't know why I put a purple color. And the style you see here, solid, so closed, open, is a hole, or cross. Cross is to indicate one important point, no? But in this case, everything is important. Entonces es a hole. Do you see the idea of the hole? This is the thing I want to see in the test. Si es a hole, you represent like a hole. By hand, in the piece of paper, or in this book. Either way. Cool? Excellent. Beautiful. Let's come back to the whiteboard. Boom. Do you see my whiteboard? Tell me something. Do you see my whiteboard?
Yes.
Yes, okay. Now, see you are clear in the vertical asymptote. I promise, guys, in the maybe not necessary today, we integrate everything. We study part by part. We study vertical asymptote. I suppose you understand very well vertical asymptote and the holes. Now let's move on horizontal asymptote. And this you need to be clear because in the test, the math department of the campus emphasize too much in this. Entonces, there are in the test several problems que ask you, es horizontal, es vertical, es horizontal, es vertical, es horizontal. Actually, I anticipate something. We have vertical asymptote. I start now horizontal. And we have one more que es slant. Slant. Asymptote. We study vertical, now we are studying horizontal, and definitely today we study slant. It's easy, but there are many rules, many analysis that you need to remember, or you copy into a piece of paper, no? And you apply in your moment that you need. Okay, let me try to explain the idea behind horizontal asymptote. This is end behavior. What mean end behavior? Well, end behavior means when the x value approaches to positive infinity or approaches to negative infinity. So our travel, our trip, our journey is in both directions of the x-axis, to the right or to the left, but too far, infinity. Entonces I want to study the end behavior. Okay, so we have this is represent all real number line, no? Infinity positive, infinity negative. Why not? This is the y-axis. I do different graph because they are different behavior, but not too much. So for example, we have horizontal asymptote. Remember, any asymptote convention is black color, dotted line, but this is horizontal. And it's a y equals something. Y equal maybe 2. 1, 2. Y equal 2. Y equal 2. Horizontal asymptote. Not necessary to in any problem, no? Depending on the problem. Okay. So one possibility is that our curve look like that or down, doesn't matter. It approaches to the asymptote because it's the asymptote, you know, the asymptote never touches. So the distance between the curve and the asymptote is smaller, but never touch. Okay. Another possibility is suppose this. Oh, in the middle we have one vertical asymptote here. Look. So we have combination. This is the most popular. Okay, we have combination vertical asymptote and horizontal asymptote. So we have a vertical asymptote at 0 vertical. Or I don't know, depending on the problem. Maybe in one specific value. And one possibility is no frequently happen, but sometimes happen is that we have a curve like that. Oh, professor, but you see that the curve never crosses or touch the asymptote. Yes. The vertical never, but the horizontal seldom. Okay, sometimes happen. And so this point is very important. So in any problem, can you determine that we have the horizontal asymptote? Okay, one next step is analyze if the curve crosses or not. Because sometimes in this case, no. In this case, no. But in this case, yes. Cross at the point. And you need to find the famous, very important point. And consider inside the game, inside the problem. Entonces, what are the criteria to understand si we have or we have no, because sometimes we have no horizontal asymptote. So the criteria is easy. Look, let me show you in detail. This is a little bit confusing because there are too many rules. Okay, the rules I condensing in this name. The degree analysis. So you are doing always degree analysis. Suppose, let me try to use my common sense. Suppose that we have a function, f of x equal 7x squared plus 2x over 4x squared minus 3. And the question that you have in front of us is, we have a horizontal asymptote. Entonces, you have two possibilities, yes or no question, yes or no. Entonces, for solving that problem, we are doing the degree analysis. Entonces, you are like, wow, what is the degree of the polynomial in the top? Degree of the polynomial in the top es 2, no? Remember, the degree is the higher exponent, no? And the degree of the polynomial in the bottom is also 2. Yes or no? Same degree. Yes. See, this number is coincident. Same degree. The answer is yes. We have horizontal asymptote. And what is the reason behind this? Because the degree, the degree by definition is the higher exponent, is the dominant. So when you analyze the end behavior of the function f of x, es obvio que the dominant, this is a new idea, dominant terms in this expression is this, at the top, and this at the bottom, right? Because everyone is increasing, I know, this is increasing, but this is increasing faster than this. This is increasing faster also, but this, no, this is stay constant, it's 3. So you ignore, neglect so you only take the dominant, que the dominant is the higher degree, que es 7 x squared divided by 4 x squared. Oh, pero x squared cancel, and the answer is 7 over 4. Okay, conclusion. You take the dominant in the top, you take the dominant in the bottom. See, it's the same degree. Nice, I love you, this case. Yes, we have a horizontal at the horizontal is at y equal 7 over 4. Okay, entonces my graph, I don't know exactly now. I have not all the information, pero es, you know, something like that. This is x, this is y, this is 7 over 4, the 7 over 4 is 1 point something, no? I don't care, it's not important now. 7 over 4 is the horizontal, and our curve, maybe, I'm not sure, look like that. Approach it in both directions to the same value. Unbelievable. To the left and to the right. When you approach it to positive infinity, or you approach it to negative infinity. The rest of the information, let's see in your moment. Now focusing, now only in the horizontal aspect. Do you understand the idea or no? This is not all of them. We need to see more scenarios for the horizontal. But do you understand so far this idea? Yes or no? Confusing. Come on, opinion. A ver, no, what mean no? Yo, Josué Torres, no es que yo... no problem, no? I didn't get that. You didn't get that. Okay. What part you don't... A ver, activate the microphone and ask me directly to understand more clear. What part is confusing, Josué? I don't hear it very well. Put the volume higher. So I understand that you don't get that, but I want to discuss, what part is confusing. Okay, look, I propose one idea to understand. I bring 2 new examples. I got lost when you got the same degree. Okay. No, I understand. This is super easy. Look. You need to know that the degree of any polynomial is the higher exponent. So we focus on the polynomial on the top, that one. What is we have 2 exponents, no? Exponent 2 and exponent 1. And what is the higher 2? Degree 2. Degree, by definition, is the higher exponent. So in the polynomial, you have different terms. 1, 2, 3, 4, 5. Any monomial contain different degree. And what is the degree of the entire polynomial? The higher number. Make sense? Okay. Let's see a couple of the examples. You help me to understand it. Suppose two function example 2 and 3. Entonces now what is the objective? What is the goal? In this example, determine C. Two questions. You solve the two questions. Question number 1. We have a horizontal asymptote. Yes or no? Secondly, at what value? So we have horizontal asymptote. It's my first question. My second question is at what value? Okay. Okay, my first function rational is h is the name of this is 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay, this is my first. The second is p, the name of the function, and p is x squared plus 7 divided by 11 minus x squared. Okay, remember I am bad guy. I put the confusing part to confuse you. You are not clear, right? Okay, answer the first question and the number 2 example. We have or we have no. Do we have horizontal asymptote or no? Remember, we are doing the analysis of the degree. What is the degree of the polynomial in the numerator? What is the degree of the polynomial in the denominator? Come on, help me. Come on, guys, this is pretty easy. All right. Saying, yeah. Saying so no. Michael is saying so no. What is saying so no? So it's the same, right? What is the answer of the question number 1 and this and this? Question number 1, do good. Okay, he said, Josué Torre, que the degree is 2. And the degree is 2. It's the same. Therefore, the answer of the first question, do we have horizontal asymptote, is yes. Answer question 1 is yes. Entonces, the second question, at what value do you believe is the horizontal asymptote? At what value do you believe? No asymptote? Wow, Michael says no asymptote. Michael, look, the rule is clear. The rule is clear. When you have the same degree, yes. Michael Lopez is 0. No, I totally disagree. No 0. No 0. No 0. What is the dominant? A ver. Sofía, Adolfo, yes. Yes, what, Sofía? Yes. Entonces, si you understand, let me know, please. At what value is the add ax squared? Michael Lopez say que es, okay, Michael Lopez have some clue, but not totally. This is the dominant in the top, and the dominant in the bottom is this, no? Michael. So this is completely negligible, that part. Boom. Entonces, 4. Very well, Michael Lopez. F4 is add. Yes, we have add y equal 4. It's our famous horizontal. Everyone understand very well this or no? Come on. This is the moment to ask me. Guys, you have to learn. You want to pass my class, you need to learn. Definitely. Okay? Josué Torres say yes. Josué, help me with the second example 3. It's saying the same problem. Do you have horizontal, yes or no? Or agua valley? Can you plug it? Yeah, of course I can. Right now. Oh no, oh no, oh no. If you want, I do. But this is not important now. No important, no important. Don't deviate attention. O sea, the attention is look in the question only, no graphic. Of course I cannot do that. I think the horizontal axis is a y 0. No, no. The answer is no. I want to explain why in a few seconds. I think the horizontal. No, you are wrong. You are wrong. I have 4. Okay. The answer is for the example 2 is yes and 4. I guarantee you 100, 300%. After I see the scenario case y equals 0. Pero no this example. This is example 4. Okay. I mean in the next, oh, you see in the next example. Okay, in the next example, the answer of the question 1 is yes or no? Es yes, no? Es yes. Yes, Michael, yeah, es yes. Es yes because he saw que the degree is 2 again, same reason, and degree here is 2, same reason. Yes or no? You take, it doesn't matter, I put intentional to confuse you. I put intentional, okay, I put x squared in the last, in the rightmost side, but it doesn't matter. You can organize in descending order, right? But the horizontal, the question at what value is no 0. It's no 0. No, it's 1. Josue say it's 1. I totally disagree. No 0, no 1. No 0, no 1. Okay, to see more clear this, what is the dominant in the top part? What is the dominant? I suppose it's this. Yes or no? Dominant is the monomial. You have competition in the numerator. Yeah, in the denominator, this is the dominant. Yes or no? Okay, yes, numerator. And denominator is minus x squared. Because this is a guy increasing faster. It's increasing super faster. This is not increasing, it's constant. This is constant. And it's increasing super faster. I did intentional to confuse you. Okay, put it in different order. So you have in the top the dominant is x squared, and you have in the bottom is minus x squared. It's obviously negative 1. And the answer is negative 1. Do you see it now? More clear? Oh, yes. Okay, look. One more idea. When you analyze the horizontal asymptote and the rational function, we are doing the famous degree analysis. And what is the famous degree analysis? You take the dominant guys in the example 3, that was tricky. Yeah, I know. I put intentionally. Of course. Because in the test I put in doesn't you never see before one similar, no? So es the degree analysis consists in taking the leading coefficient, o sea, the dominant term in the top is the dominant term in the bottom. Okay. And that's it. No, this is just the beginning. We continue another scenario of the horizontal. Okay, horizontal, is complicated. No, it's not. Because we have several cases. Suppose example 4. In example 4, we have a function. Let me call h of x is equal 5 divided by 4x squared plus 9. Okay, entonces we focus again. Okay. To remind you, I believe que you did send the reading. I send the test. What test? I remind you, I believe, what test you are talking about? Test 3. The third. Okay, I will send today. because that's ending Monday. No, Monday no. No. Don't worry too much for this. Remember, I send the test when I finish the chapter, I finish the review. I can modification the due date according to dynamic. Remember, we have a holiday, and with holiday we lost 1 day. No. Don't worry. If you want, I send today. But today when I come back, because I have the same class I have on campus. I need to travel to the campus. I spend all the day in the campus. Yeah, I come back. You want, I send. I send when I send the video of this. Okay, focusing 100% of this gets complicated. In this case, the question is the same. Do you have horizontal? At what value? The same classical question. But you are doing the famous degree analysis. Es obvio que the degree of the polynomial in the top is 0 because it's a constant. Es x missing, pero to the 0 que 1, no? This is the reason que es 0. And degree of the polynomial in the bottom is 2. It's the higher exponent, 2. And when this situation happens, when the degree of the numerator of the degree of denominator is bigger degree of the numerator I want to call a special case. This is the regular. So the other example that we're doing before is regular case. But this is special. And yes, the answer is yes. We have horizontal asset. But this is special. And special always happen at y0. And let me try to explain this idea. The situation that we face now is the division 2 polynomial. However, one polynomial in the bottom increasing faster, like this. This is not actually not increasing. This situation not necessarily is when the degree is 0. It's in general, when the degree of the denominator is bigger, that means increasing faster. And the value is 0. Why 0, professor? Look, let me show you a straightforward example. Suppose you have a constant 1. I put 1 to make easy the operation. And suppose that you divide it by one thing is increasing faster. Suppose that at the beginning is 10. Oh, this is 0.1 and decimal. Now I want to increasing 100. It's 0.01. And you increasing 1000. Is 0.001, no? And so on. See, I increasing 1 0 here. You see, always is positive. But the quantity is smaller, and approach it to 0. Approach it to 0. Approach it to 0. Approach it to 0. Super clear? Let me now to summarize the information that look like confusing. Horizontal asymptote. We have two scenarios. The most popular is the regular case, in which the degree of the numerator is equal the degree of the denominator. Okay, entonces the answer is yes, we have at what value, at the value que is equal y equal the division leading coefficient and the top leading coefficient and the bottom, denominator. Keep in mind, please be careful, okay, you need to express it in descending order of the degree, no? Because I put intentional, in this case, okay, put 11 minus x squared. No, it's not organized. You put minus x squared plus 11. Oh, now the coefficients are negative 1. And we have another case que es especial. Pero especial is no, que es weird. I call it special because I want to have that name. Que es when the degree of the denominator is bigger. The degree of the numerator. Cool? Clear the idea or no? Clear the idea or no? What part? What part? The question, your question must be specific. Okay? What part you don't understand? What part do you want to repeat?
Like the degree.
Okay. Repeat. Focus, please. To analyze the horizontal asymptote, you need to do a famous degree analysis. What is that? Degree analysis is you analyze the degree of the numerator, boom, one number. You analyze the degree of the denominator, boom, another number, and we compare both. See, the degree is the same number, 2, 2, 3, 3, 4, 4. Yes, we have horizontal. Add the y equal the division of the leading coefficient top divided by bar, because they are the dominant. This idea is clear?
Yes.
Secondly, we have one special case. Okay, when you are doing one more time in another example, the degree analysis, you see, wow, the degree.
La reproducción de canciones específicas solo está disponible con Amazon Music Unlimited. Aquí tienes una estación basada en la canción YMCA de Village.
Alexa, cállate. Do you hear Alexa? Well, again, look, I say something I don't remember. Okay, look, the specialist when the degree is different, but degree and the denominator is bigger. Suppose que I analyze the degree and the denominator is 3, and the degree and the numerator is 1 or 2. Entonces now, yeah, definitely we have horizontal, but add y equals 0. I forgot to write this. Add y equal 0. Now it's clear?
Yes, it's clear.
The problem is that you have to remember this information, or you copy in your notebook, you know, and you consult throughout the problem that we are doing after that, no? So now you little by little doing the practice, see how I solving the problem. Plus, when you are doing your homework, remember, I insist, the homework is not mandatory, but it's important. It's the practice before the test. Entonces, some people in the test too don't do the homework because I don't care. Okay, and take the test and get ridiculous grade, 50, 40, 45. And it's logical. Entonces now, no ask for help. No ask for help. Last time I explained, Elsa explained for everyone what is the way. Elsa get 100 points in any test. Because Elsa, when you don't understand, well, first of all, Elsa is the decay. Okay. Now, any problem, a human, and stuck in one problem, immediately send me, I solving, I send back to say, si I got it or no. Entonces, I insist until. This is the procedure. Oh, no, suppose que you don't like me. Okay, because you, I don't know why it happened, the students believe that if you ask to the professor too much, the professor suppose that you are no good student. No, I lie. And then you want to suppose that you believe like that, so you ask for the tutor. The tutor is available in person and online. And you need to create appointment. But the problem is que you need to planning. You planning your time. So you're waiting for the last minute. In my personal opinion, this class is not hard. However, it's the most popular class. A lot of people in Miami-Dade College, in Broward also, we are teaching in both campus, fail. Because it's a little bit different to the previous mathematics, que es just intermediate algebra. Intermediate algebra is manipulation. If you learn the procedure, the mechanism, you pass the class. But this no, because this is a little bit, conceptually, because you need to understand very well to pass this. Okay, let's see one example, and you help me to understand the famous horizontal acetone that nobody understands very well. Okay, suppose this is example. I don't remember what number is this example. Example 3, no? I guess. I don't know. Suppose the function f of x equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay, cool. So my question is, again, question 1, we have or no? Question 2, agua value. Yeah, I have question 3, que es the new, que I want to illustrate. Cross or don't cross. Okay, let's focus on the first question. We have horizontal, yes or no? And justification why. So existe 50-50, o es yes o es no. Pero justification why. Come on, who there? Yes. Josué Torres, say yes. Why? Reason. Yes. Now, reason. Because to do. Degree of this is 2. And degree of this is 2. Entonces, by the way, this is the regular case. No complication, no problema. Vamos, Sofía. Dice yes. Okay. Both have the same square. Yeah. And likewise, you put QB here. Suppose que I put a QB here. Yeah, I put a QB here. It's the same idea, no? It's 3. It's the same degree. So you need to keep in mind.
Cubic square.
In this case, it's square, pero no necessarily it's 2. So you have, for example, another example que es 3. The answer is the same by the same reason. Or 4 or 20. Cool?
Cool.
Okay. Now I need to answer next question, que es agua value. Agua value. Entonces now this is more complicated. F4. Josué says 4. Why go 4? Everyone else agree or disagree? And where come from? This 4? I don't know. Where come from? It's leading coefficient. Who is the leading coefficient? A divided by 2. And the rest is completely ignored. Completely negligible. Disappear in my mind.
Professor, The value by dividing the numerator and the denominator.
Exactly. Es numerator. Es numerator divided by 4 que es denominator. But, in this case, I am doing like that because it's the same degree. Si es different degree, no. Si es different degree, no, pero no, I don't want to complicate it. It's like that. Okay, no, in the example, in the advanced example we're doing after that, yes. The answer is 4, and 4 come from of the division A divided by 2, okay, are a leading coefficient. Everyone follow me so far? Now, yes, cool. All right, I want to explain the complicated part. Okay, sometimes when you, mandatory, when you discover that our problem have horizontal asymptote, yes, when the answer is yes, you need to investigate if the curve, our famous curve, so what happened if different degree? Sophia, I explained before, okay? If the degree, suppose, Sophia, wake up, look, suppose, two scenarios, a x cubic plus 9x minus 5 over 2x squared plus 1. It's a one possibility. Another possibility is I change a little bit the original problem. Ax squared plus 9x minus 5. I copy exactly the same. Yeah, I copy now 2x cubic plus 1. Let's analyze this first. Analysis of the degree. What is the degree of this polynomial? 2. What is the degree of this polynomial? 3. And I explain that when the degree of the denominator is bigger than the degree of the numerator, is a special case. So the answer is, we have horizontal. Yes, we have. At what value? At 0. Okay, special is always 0. Okay. Do you understand this or no? This is out the problem. You deviate to me from the problem, okay? Okay, Sophia, I understand. What about this guy? What about this guy? Degree of this S3?
And the degree is
second?
Yeah, it will be
2. So in this case, no equal.
No.
And degree of the numerator is bigger than. So the answer is no.
No.
What? No horizontal asymptote.
And
no,
the value.
Yes, to have horizontal, two conditions, equal degree, or degree of the denominator bigger. But the degree of the numerator is bigger. No, we have another thing we study in few minutes. Clear? Clear? All clear?
Yes.
Okay, cool. I know it's complicated. It's complicated to explain. It's complicated that you remember that. It's up to you, not to me. Okay, so now let's focus on the complicated part. I want to investigate mandatory when I determine si we have horizontal. Si the answer is yes, mandatory, you need to investigate if my curve crossed or no, or doesn't cross the the what? The horizontals. Entonces I determine, yes, of course, at 4. Okay, no problema. Entonces, to investigate that, you take the original expression, ax squared plus 9x minus 5 divided by, I copy the original product is given at the beginning, and you enforce it to be equal 4. Sometimes, the majority of cases, you try to solve this equation. Si this equation have no solution, it's because the curve never cross the horizontals. See, we have solution, it's because cross. Let's do it. Let's do it quickly because it's too easy. You apply cross multiply here, cross multiply, and you multiply ax squared plus 9x minus 5 times 1 is equal 4 times 2x squared plus 1. Cross multiply, cross multiply. Do you see that? Okay, so now I have equation, and using my skill in algebra, I try to solve this equation. You apply this derivative here, ax squared plus 4, because 4 times 1 is 4. And now, wow, I see this part cancelled, it's the same. And my equation is like that, look like that, x minus 5 equal 4. Okay, 9x is equal 4 plus 5. 4 plus 5 is 9. X equal 9 divided by 9 is 1. Wow, so we obtain one value, does that mean it is crossed? And this is very important point, because you omit, you have big trouble with me. Okay, so you need to investigate the fact that we have horizontal asymptote. Yeah, it cross. But I need to express it like an order pair. Is 1 comma because of the x value. What is the y value associated with that? I need express it. It's for obvious. Josue Torre, you are a smart guy. 1,4. Because it's the value of the horizontal. Make sense, right? Make sense? Make sense or no? Yeah, cool. Now, yes. I want, at least this example, I want to show you in Desmos. I want. Here, over there. Let me share the screen to Desmos. Okay, Desmos now. Okay. Do you see that? Well,
Yes.
Okay. Example, I don't know, 3. Yeah. Look at that. Boom. This is the graph. Let me flash it. Boom. And we determine, look at the important. Okay, we have a horizontal asymptote out 4. No? Okay, the convention is, look, you click here and you put black color and dotted line. Okay, this is a convention in our graph. Everyone in the world doing it that way. And we found the famous point 1,4, get this, and you see clear, get the curve, get the red color, cross it, the horizontal asymptote. And let me show you one more detail. The horizontal by definition is when you increasing the x value 10, 15, 20, 25, 30, 40, it's infinity. The curve approaches but never touch the asymptote. Only cross it in 1. It's a super important point. If you forgot to investigate this in the test, you are in big trouble. Okay? It's only 1. And likewise, happen in the negative infinity. Look at negative number, negative huge number. Is approach it, but in this case, approach it down. I don't care. But never touch. Only cross it N1. Do you see that?
Yes, yes.
Boom.
Yes.
Okay, entonces keep in mind, remember to analyze the horizontal, you are doing the degree analysis, and we have two cases. When the degree is the same, yes, doing the division leading coefficient. And special, when the degree at the bottom is bigger than 1, than 2, I don't care, bigger, in general bigger. Yes, it's special at Y0. I promise, can we see more example? Maybe not today, of course, today is short day, Monday, about that. Okay. Let's come back to whiteboard. Do you see my whiteboard?
Yes.
Let me erase.
Yeah.
Well, we have the last is asymptote, que es slang. Slang asymptote. Well, the slang asymptote is different. Is when suppose the example for the slang is the function is x squared plus 1 divided by x minus. And we are doing again the degree analysis. Degree 2 of the polynomial at the top and degree 1. Entonces, when degree of the numerator is equal degree of the denominator plus 1, no plus 2, no plus 3, plus 1, so one more. Yes, we have. A slant asymptote. And a slant asymptote, a horizontal asymptote, is a concept that we analyze together because they are mutually exclusive. So you have horizontal, we have no slant. See, we have a slant, we have no horizontal. Mutual exclusive. So, and one line guy I want to study next Monday. Monday we are doing. Monday is the most important day. Today is the day of the theoretical. Monday we are doing 3 strong example of the rational function. You will analyze everything, and you need to remember the concept that we discussed today. Well. So now in the analysis, we are doing simultaneously horizontal and slant. Because if you have horizontal, forget about slant. If you have slant, forget about horizontal. Mutually exclusive. Okay, so what should I do? What mean to be slant asymptote? Well, okay. Slant is oblique line. I don't know exactly, see like that or like that. That depending on the slope, when the slope is positive, it's like that, no? Equal the slope is negative. It's like that. And you know, horizontal is like that. It's totally flat. Horizontal is slope 0, you know? And vertical is like that, is to be undefined. So slope is undefined. I remember, I suppose you remember very well in intermediate algebra, these ideas. Slope positive is going up, slope negative is going down, slope 0 is flat, slope to be undefined is vertical line. But forget about this. The most important is now analyze what is the slant asymptote equation. What should I do to find that? Well, no, you are doing division. You are doing division, long division, long division, long division. That is the reason that we learn intermediate algebra, long division. Let me refresh your memory. So basically, I need to divide x squared plus 1 divided by x minus 1 in this example. So you are doing long division of the polynomial. You copy the format for the long division like that. And you copy the dividend inside the box. But very important, when the one monomial is missing, you put a 0. So we have no linear. You copy this. This is this. X is missing, and this is that. But this is important. The organization in descending order 2, 1, 0. And this is the divisor. And you copy outside the box, and you start doing the long division now. Long division. Long division. This is I. Okay, es obvio que es x because x times x is x squared. And x times -1 is minus x. Minus 1x, no? But remember, division procedure is a sequence of multiplication, subtraction, multiplication, subtraction, multiplication, subtraction, always. By subtracting, you change the sign. Boom, don't forget that. So this is cancel out, and this is only 1x. 0 plus 1 is 1. 1 is invisible, you know. Now I finish. No, why no? Because the degree of this guy is 1, and the degree of the divisor is also 1. So we cannot stop. We continue. You stop when the degree of the potential remainder is less than 1, the degree of the divisor. So I bring down this one, bring down, and we continue the division. It's obvious it's plus 1, no? Plus 1, because 1 times x is x, and 1 times -1 is -1. By subtracting, you change the sign. This is cancel as always happen, and 1 plus 1 is 2. Boom, I finish. Okay, now, I suppose you remember long division, yes or no? If you don't remember, I send to you to the intermediate algebra. You go back. If you forgot, no problem. You refresh your memory. Yes or no?
Yes.
I suppose, Elsa, you remember very well, no?
Yes.
Yeah. Name the interpretation. This original expression gets given at the beginning is equal the quotient, okay, the quotient is x plus 1. Who is that? This is the quotient. Quotient. Plus remainder, que 2, remainder, que 2, que 2, over divisor, que es x minus 1. Divisor. Guys, we are doing nothing. You always, the only thing you are doing is this expression gets given at the beginning. You using algebra, you find another expression gets equivalent 100%. It's the same algebraically speaking. It's the same stupid thing, right? But you can see clear like a water now. Que that part, que es the quotient, represent a line y equal x plus 1. And this is the famous slant asymptote. Okay? Finish. No, because collateral, I can see collateral, I can see here, I see a vertical asymptote. Yes, at x equal 1. So when you are doing the graph of this function. Let's do it by hand and after Desmos. See, I finished the class today. To say spending, but the Monday is important day. Okay, we have a line that represents the slang. Oh, I need to remember that this is analogous to say y equal mx plus b. B is 1. B is 1. Therefore, the y-intercept of this line is at the point 0,1. I plot that. Boom. 0,1. And a slope is also 1. Look at that. A slope is the coefficient in the front is invisible 1. It's 1. It's a wrong and rise. This is the ratio between wrong and rise. Both are 1. No, it's 1 over 1 because 1 over 1 is 1. No, it's positive. That means it's up. There's a 1 to the north direction and 1 to the east direction. I get the second point, get the point 1,1, and the story I connected by the dotted line because of the slant asymptote equation graphic. However, we have another asymptote que this, que es vertical. A 1 here and 1 vertical. Okay. So this is important information. We have a slant asymptote and we have vertical asymptote. And the rest I want to teach next class. Well, you can put in decimal, but no, I want to teach the methodology to do perfectly the graph of this. The graph look like that. Boom, boom. Boom, boom. Okay, it's asymptotically. When you're talking about asymptotically, is the curve approach it, but no touch. In general, one special point cross, but in general, no touch. I want to show you Desmos. And now, I want to finish the class. Okay. Desmos. Do you see my Desmos?
Yes.
Okay, example 4.
Yes.
Oh, Do you see or no?
Yes, I see it.
Okay, look at that. The curve I use in blue color. And here I plot 2 lines. The vertical asymptote at x equal 1, look at flashing. And the slant asymptote at y equal x plus 1. Slant, oblique line. And you see how the curve approach but never touch. Never touch. Amazing. Look. Okay. Now, next class, we integrate everything in 3 famous examples. And include another ideas that you know. A typical point like y in a set, x in a set, and how many additional points you need to plot to do by hand. But actually, remember, nobody do by hand this. Everyone in the world using software. Remember, we are living in 21st century, United States of America. We have internet, we have Desmo, or not necessarily Desmo. They are another software, but Desmo I like so much because it's very intuitive, right? Okay, guys. Thank you. Bye. I am leaving.
Bye, Professor.